this is Calculus 1, Chapter 1.1. In these videos, I'm going to talk about definition of functions, review of functions, function notation, and also how to find zeros of functions. So what is a function? Functions is a set of rules for assigning each input in a set called domain to exactly one output in the set of range. So the input is domain, the output is range. And normally we would use X as the input. We use X as input and we use Y as the output. And in a function notation, we also use f of X to represent Y. So f is the name of the function, X is the input. And if I say f of X, that means give me the output where X is the input. Okay, so Y is actually the notation for f of X. We call it function notation. And notice f of X is not f multiply X. F is not a variable. It's just a name of a function. So for example, I have this function and a formula where f of X is x squared minus 3x plus 5. And I want to find f of 3. So in this case, X is equal to 3. So the input is 3. And I want to find Y that is having an input 3. So I would write f of 3 equal to, and I put in 3 squared because 3 is going to replace the X values. X is the placeholder, so it is the input. Minus 3 times 3 plus 5. So that would be 9 minus 9 plus 5 equal to 5. And the second one we want to do is f of negative 4. So again, the X is negative 4. So I put negative 4 in the formula. Square minus 3 times negative 4 plus 5. And that would give me a 16 minus a negative 12 would be plus 12 and then plus 5. So this gives me 28, I guess. 28 plus 5 is 33. Okay, so we can find f of anything we want by plugging in whatever that shows up in the input area here. We can actually put a variable, in this case 3a, as an input. So I would replace x by 3a, 3a squared minus 3 times 3a, and then plus 5. So this would become 9a squared because 3 also need to be square. Okay, let me go down a little bit. And then minus 9a plus 5. And in this case, I cannot combine like term for 9a squared and 9a because they are not like terms. So this is the answer. A more difficult one would be I plug in actually x plus h as the input. Now x plus h is two variable, is a sum, but I'm treating this as the whole input. So whenever I see x in the formula, I'm going to replace it with x plus h. So the original function is x squared, so I'm going to replace x squared by x plus h, and I have a 3x. I'm going to just, anytime I see an x, which is the input, I'm going to replace it by x plus h, right, plus 5. Okay, so this is what I should simplify. X plus h squared is x squared plus 2xh plus h squared. Why? Because x plus h is x plus h squared is x plus h times x plus h. So it's not just x squared plus h squared, but it involves 2xh. And then I minus 3x, and then I plus 5. So is there any like term that I can combine? I have a xh term. I don't have anyone. I have x squared term, but there is no x term. So these are all unlike terms. So this is the answer: x squared plus. If I want to, I can put the x next to each other, 2xh minus 3x. So these are all x term. And then I have x squared term and a minus 3x term and a plus 5. Okay, so this would be the answer. So this is called function notation of evaluating a function given a formula. Example 2 would be if I want to evaluate something not just for f of x or f of something, but something called a difference quotient. This particular expression shows up a lot in calculus, so we want to do that. So let's say what is the difference quotient is f of x plus h, which we have done already. We know that whenever we see x, we just replace by x plus h, and then minus f of x divided by h. In chapter 2 and 3, you will notice that this shows up a lot. So let's practice doing it. So what is the difference quotient? If my f of x is x squared minus 6, I would do x plus h square minus 6. So this is f of x plus h. And then I'm going to minus my f of x, which is just this whole formula. But remember, I'm subtracting the whole thing, so I have to parenthesis it. Remember to parenthesis it. If you don't, you're not subtracting the whole f of x, right? And then divided by h. So this is called the difference quotient. So let's multiply it out and simplify. X plus h squared we just did is x squared plus 2xh plus h squared minus 6 minus x squared and then plus 6. Why? Because I need to distribute. Can I change to another color? No, I don't know how to change to another color. Maybe later. We'll just use this black color first. So, oh, I did. I don't know how to change it back. Okay, so divided by, divided by h. Okay, so this would become, so you can combine some like term, x squared cancel, 6 and 6 cancel. So I have 2xh plus h squared over h. And if you notice that both of the terms in the top has this h that we can factor out, so it's 2x plus h over h, and they cancel, so the final answer is 2x plus h. Okay, so this is just putting in function, evaluating a function. So this third example is I have a function which is a piecewise function, meaning it has two formula, and I'll use one if x belongs to a certain domain versus the other one, x squared minus 1, if x belongs to a second domain, which is x greater than 2. So let's see, I want to find f of negative 2. So this means my x is equal to negative 2. Which formula should I use? Obviously, negative 2 is less than 2, so I should pick this one, right? So this is less than 2, I would use, so f of negative 2, I would use the first formula, will be negative 2 times negative 2 plus 4. So that means 4 plus 4 equal to 8. What about f of 1? 1, this is x, right? 1 is greater than, is it greater than 2? No. 1 is less than 2 still. So I should not pick the second formula. I should still stick with the first formula, right? So it will be negative 2 times 1 plus 4, which is less than 2. So that would be negative 2 plus 4 equal to 2. If I do f of like maybe 5 or 6, then I will use the second one, right? So piecewise function, that's how you evaluate a function value. So next topic, so we're going to go over is how do I represent a function? We say a function has rule, right? So what are the way to represent this rule? So the first way is to represent it like a table. So it could be a horizontal table, it could be a vertical table. So what happened is you will say x and y. You will list those values. You will say, oh, if x is 1, y is 4. If x is 2, y is the output supposed to be 7. Whatever that you want. X is 3, y is 10, whatever that you want. So each x is related to the corresponding y as the output. So these are f of 3. So 10 is equal to f of 3. And if I have a graph, every point would have an x and y. The y is f of x. F of x is the y value, and then each point on the graph would represent the function value. And if a formula, we would just plug into the formula, right? But plug in the x value to the formula and calculate it. So in each of these notation representation, we'll do an example. So I have a k of x given as a table. What is k of 9? So remember, 9 is x, is the input. So x equal to 9 is here. So, and then my corresponding y is 27. So we say k of 9 equal to 27. The second question is what x will give f of x equal to 9? F of x is y. So what x value would give me y equal to 9? Y is here, the second row. So 9 is here. What is the corresponding x? X is equal to 18. Because this is the corresponding x value for f of k of x equal to 9. What is the domain and range? Domain is all the x values. So it will be, in this case, with 0, 3, 6, dot, 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 all the way to 27 as listed. We write in a set. And range are all the y values, 6, 27. So you basically list it like a roster. If they're double, if they shows up double, you don't have to relist them. You just write it once. So there's a 18, right? And then there's a 9. There's a 21. Did I do 21? Yeah. Oh, yeah, I think I have 21 already. So I don't have to write all of them. So just write domain and range. So all the one that listed. Let's see f of x function notation if I have a graph. So if I have a graph of a function like this, I want to find f of -3. Oh, I should say f of -3. So this should be f of -3. So that means x is -3. So I will look at x equal to -3, and I find out where my point is on the graph. So this is the point. So I go down and look at this point. And what is the y value? The y value is 5. So this point is -3, 5. You see x is -3, y is 5. So it's -5 actually. -5 is down 5. So what x will f of x equal to 3. F of x equal to 3 means y equal to 3. So y is equal to 3 here. What are the x values? So you look across. There's actually 2 of them, 1 and -1. So actually x would be 1 and -1, so that f of x is 3. What is the domain? Domains are all the x values in this graph. So in this case, all the lowest x value is -3, including -3. And the highest x values in all of these points on this graph would be 2, but not including 2. So we write it this way, interval notation. Range is all the y value that's specified in this graph. And in this case, it would be, what's the lowest y value? It is -5, right? So this is the lowest y. And what's the highest y that I can go in all these points on this graph is 4 and including 4. So that is the x and y. So this is how we evaluate function given as a table, a formula, as well as a graph.